calculus. I want you to know that calculus itself is divided in two parts. We have the differential calculus and we have the integral calculus. So in this part, the part I'll be taking first is the differential calculus. So don't forget to subscribe, like, share and comment so you can know on your notification, so you can know when I drop for integral calculus also. Okay, for this differential calculus, I say what is the meaning of differential calculus? It simply means I want to find the slight change in a value. That's the meaning of differentiation itself. Like, okay, that means I have a value. What slight change can that value has? That's the differentiation part. Now, for instance, now I said if I want to differentiate, I have the first principle, I have the product rule, I have quotient rule, and I also have the last one, which is chain rule. Although that's for that, we still have some other differentiation of circular, we call it circular function. They are also called these trigonometric functions. I'll be saying that after I explain all these parts. Now for this first principle, we said whenever you say your y, which is your dependent value, is equals to ax, which is our independent value, raised to power any value, which is n, then the differentiation of that thing will be taking your power, multiplying it with your base, and deducting your power by 1. What do you then mean? What it actually means is that if they say, let's assume that they say y equals to 3x squared. Now in this place, they have to find the slight change in y, that's dy dx. How do you find it? Now using this first principle here, we said whenever y is equals to ax raised to power n, then my dy dx is then equals to nas raised to power n minus 1, which means what they actually say here is that I'll multiply my power with the base, I'll multiply this power, which is 2, I'll multiply it with the base, which is 3x, all raised to power the power again. What's the power? 2 minus 1, and that's then equals to 2 times 3 is 6x raised to power 2 minus 1 is 1, and the final answer is 6x. Now this thing that I did here, this first principle of a thing, is actually coming from somewhere. And where is it coming from? Let's just take it. Okay, I said we can actually solve this example again. So let's solve it. We say y equals to 3x squared. Now let's find a slight change of y with respect to x. That means I can say y plus delta y, which means if y changes, we are going to add the small change, the infinitesimal change of y. I'm going to add it to y itself, equals to 3 into brackets. This x also is going to change, because if x did not change, y will never change, because x there is the independent value. Y there is dependent value. Y is depending on x, so x plus change in x all raised to power 2. Now from here, what can I say? I can actually continue from here. I can say, since I'm finding my aim is to find delta y to delta x, and remember something, when I say I take the limit of delta y of delta to delta x, and I say delta x approaches 0, this thing here becomes dy dx, which means in my aim in this place is to find delta y divided by delta x. So that means I can take this y to the other side in this place. I can say delta y is then equals to 3 into brackets. Let's open this bracket. That's x squared plus 2 times this, that's 2x change in x plus change in x squared minus y. So from here I can say delta y is then equals to 3x, I'm opening this bracket now, 3x plus 2x, then 2 times 3, that's 6x delta x plus 6 delta x squared minus, what's my y? We have said earlier that y is equals to 3x squared. Sorry, opening this bracket, I'm going to say x squared, so it has balance. From here I can say change in y is then equals to 3x squared minus this 3x squared plus 6x delta x plus 6 delta x squared. From here I can say delta y is then equals to 3x squared minus 3x squared, that's 0. Then we have, what I'm left with is 6x delta x plus 6 delta x squared From here, delta x is common to both, so I can factorize it. I can say delta y is then equals to delta x into bracket 6x plus 6 delta x. So divide both sides, divide all through by delta x by delta x. Delta x can cancel delta x, cancel delta x. So what I'm left with here will be okay, delta y divided by delta x is then equals to 6x plus 6 delta x. So let's say take limits of delta x as it approaches 0. So what will I be left with? That will be, anyway I say delta x, I'm putting 0 there, and I've told you that whenever I'm taking the limit of delta y to delta x, that means it will change to dy dx equals to 6x plus 6 delta x. So from here I can say, taking these limits to be 0, that's it, delta y to delta x will change to dy dx equals to 6x plus 6, delta x is taken to be 0 into bracket 0, so dy dx is then equals to 6x plus 0. That means dy dx is then equals to 6x, equals to 6x. Final answer for that. So you don't need to cram before you know differentiation. Differentiation is not even something that we can cram on. After explaining all this, we are still going to solve a series of questions, so don't let's waste much of time on this. So moving to the next one, that I said product rule. This product rule, where can I apply product rule? This product can be applied when you have multiplication of two independent value. Maybe let's say y equals to, into brackets, 3x minus 4, then multiply by 2x. Now actually you can actually open this bracket, then you apply your first principle, or you apply product rule itself. Now okay, let's first take it by first principle. If I say y is then equals to 2 times 3x, that's 6x squared, then 2 times 4, that's minus 8x. So for me, applying my first principle, I can say dy dx is then equals to 6 times 2 is 12x minus 1 times 8 is still 8, and that's the final answer for that. But as I want to apply product rule, I can say y is then equals to 3x minus 4 multiplied by 2x. So take this to be u and take this to be v. So that means from here, since u is then equals to 3x minus 4, so my du dx, that means I'm differentiating u with respect to x. That will be, differentiate 3x, that will be raised to power 1. 1 times 3 is 3. 1 minus 1, that's 0. S raised to power 0 is 1, so ordinary 3. Whenever you differentiate a constant, you are going to have 0. How you get that? I've explained it in one of my video when I drop video for limitation. You can check it out for there. Okay, from here, that's for du dx. Okay, let's take for v also. V equals to 2x. That means dv dx will be equals to ordinary 2. So bringing my rule, my product rule here, they said dy dx for product rule is equals to dy dx equals u dv dx plus v du dx. So that means from here I can say my dy dx is then equals to, calling for my u. What's my u? U is 3x minus 4, that's open brackets, 3x minus 4 multiplied by dv dx. Multiplied by dv dx, dv dx is 2 plus my v is 2x multiplied by du dx. Du dx is 3. So finishing this thing here, I'm going to say 2 times this is 6x, 2 times this is minus 8, plus 2 times 3x, that's 6x, and then that will give me 6x plus 6x is 12x minus 8. Final answer for that, which is the same thing as what I got in this place, 12x minus 8, 12x minus 8, which means in differentiation, what you just need is just to understand the basic. Once you understand the basic, it will be easy for you to solve. So moving to the next one, I will just say quotient rule. For this quotient rule, they say whenever we say y is equals to two independent values dividing each other, then my dy dx in that point will be v du dx minus u dv dx divided by v square. It means I'll be calling one value, the one at the top, I'll be calling it u, and the one as the denominator, I'll be calling it v. So taking that, okay, let's take for instance, let's say y equals to 3x raised to power 2 minus 4 divided by x raised to power 2. Now from this case, I know by now you might be thinking that can't I apply first principle? I should apply first principle to the numerator, and I should apply first principle to the denominator, then I will not divide it. It won't give you the same answer, because this thing here is change. It's talking about change in a value. Okay, that means from here I can actually say something. I can say here, which is my top, I can call it my u, and here, which is my bottom, I can call it my v. Which means for me, I can say u is equals to 3x square minus 4, then du dx will be equals to 2 times 3, that's 6x. I've told you, whenever you are differentiating a constant, it becomes 0, so that minus 4 is useless. Then also my v is equals to x square, then differentiating this, that's dv dx, that I'm going to have 2 times x, that's 2x. Now applying that formula that said as dy dx is equals to v du dx minus u dv dx divided by v square. So I'm going to say dy dx is then equals to my v is x squared, that's x squared multiplied by du dx is 6x minus u is 3x squared minus 4 multiplied by dv dx, which is 2x, everything divided by v square. My v in this place is s square, that's x square all raised to power 2, and for me I can say this times this will be 6x cube. Let's open this bracket first, minus into bracket 2 times 3, that's 6 times 3 is 6x raised to power 3, like that. Yes, and from here let's finish it. 2 times minus 4, that's minus 8x, then we close the bracket. Everything here divided by 2 times 2 is 4 from the law of indices, that's s raised to power 4. In this thing from here, we can say that is then equals to 6x cubed minus 6x cubed, that's 0, so that one has gone. Minus times minus is plus, that's 8x divided by, we say this one was raised to power 4, s raised to power 4, and then that's then equals to x here 1, x in this place is 3 places, that's 8 divided by s raised to power 3, which is the same thing as 8x raised to power minus 3. Now if we had used first principle, will it give us the same answer from here? Okay, let's check it. This times this is 6x minus 0 has gone that way, divided by this, that's 2x. X we cancel x, that's 6 over 2, that's 3, which is not the same thing as this. Hence this is wrong, but this is correct. So note that for what is that? For quotient rule. Now moving to chain rule. What's chain rule saying? Chain rule saying that whenever my value, my independent value now, is now in a bracket, like I'm adding it up and I'm squaring it, then something will happen. What will happen to the change? Now let's view it together. From here, using this chain rule, we can say, for instance, let's say y equals to 3x square. Let's say 3x square minus 4, everything raised to power, let's take a very big value, maybe let's say about 8. So find your dy dx. Now how do I find this one here? You can actually see that from this place they said make that one in the bracket, make it u, isn't it? So the one in the bracket here, we can say u is then equals to 3x raised to power 2 minus 4. Now if I'm differentiating u with respect to x, that will be du dx, which will be equals to, using first principle, 3 times 2, 6x, minus 4 has gone that way. Okay, that means from this place, since everything in this bracket is now u, I can say y equals to u raised to power 8. Do you get? Yes. From here, differentiate y with respect to u. That will be 8u raised to power 8 minus 1, 7. So solving this thing in chain rule, that says dy dx equals to du dx times dy du. So I'm going to have my du dx is 6x, that's 6x, times my dy du is 8u raised to power 7, and that's 6x times 8 into brackets. This u, we have said the value of this u before, that it was 3x minus 4, 3x square minus 4, so 3x square minus 4 all raised to power 7. That's my final answer. Here will be 6x, no, 6 times 8, that's 48, so 48x into brackets 3x square minus 4 all raised to power 7. Now let me show you a very short course that you can use for this chain rule whenever you have a chain rule, so you don't need to be going through all these threads. Previous question, having to know that y equals to 3x square minus 4 all raised to power 7. Now how do we do this? The first thing you must do is that you must differentiate this inside part and bring it out. So if I differentiate this inside part, what would I have? I'm going to say dy dx straight away will be differentiating this inside part. I'll be having 2 times 3, that's 6x. That's 6x multiply by what now? Anything I have as my power here, I'll bring it down. Now bringing this thing down, that's times 7 multiply by what now? What I have in this bracket, just rewrite it. That's 3x square minus 4 all raised to power. Remember law of first principle, it must hold. So from here you can say that law of first principle must stand in this place. Since you have brought this 7 down to this place, then it must reduced by what? By 1. That's raised to power 6. So you can say then that's then equals to 6 times 7. 6 times 7 is 42 x raised to power ordinary x into brackets 3x square minus 4 all raised to power 6. Now compare it to the previous one that we solved here. We said, oh, it was everything raised to power 8. Okay, no issue. Now let's take it again. Y is then equals to 3x square minus 4 all raised to power 8. Differentiate this, that's dy dx equals to, the first thing, differentiate this inside part, that's 6x multiplied by, bring this one, this power, bring it down, times 8 into brackets, rewrite it again, that's 3x square minus 4, then reduce this one by 1, 8 minus 1, 7, 6 times 8 is 48x into brackets 3x square minus 4 all raised to power 7. Then you are done with that, which is the same answer that we got for the previous one that we solved here. Okay, moving to the last part that we said, trigonometric functions. Now when I have these trigonometric functions, they are actually very, very simple. This is just that I said the first one is that if I have sine ax, like if y equals to sine ax, they said dy dx is then equals to, what they actually mean here is that differentiate this value in the front of sine. So if I differentiate this value in the front of sine, what will I have? Remember, if you differentiate ax from first principle, that's ax raised to power 1, this one will come to the back, that's ax raised to power 1. This one has come to the back, that's 1 minus 1, that's ax raised to power 0, and that's equals to a into bracket 1, and that's equals to a. That's why they got this a that you can see in the front of this place. So the y dx will be equals to a cos ax. Now from here, what if I have cos ax? That will still be minus sine ax minus a. I should be writing error, minus a sine ax. If I differentiate tan also, I'm going to have a sec square ax. If you now differentiate exponential function, that's if y equals to exponential function of any value, Okay, let us know that there was 2 on this place. Now, how can you differentiate this kind of thing? It's very simple. Just differentiate this one that you have as your power, then use it to multiply the whole question. So that means the y dx in this place will be equal to, if I differentiate ax square, I'm going to have 2ax. So that will be 2ax all raised to power exponential raised to power ax square. That's for that. But for this place, what they actually have is just xa exponential ax. So if I differentiate, oh sorry, there's no a here. So if I differentiate this thing, I'm going to have a multiplied by the everything again. That's exponential a raised to power exponential ax. Okay, moving to the next one. Now we talk about what again? Logarithm. Yeah. If I have logarithmic function, how do I differentiate it? It's actually very simple. For instance, I say y equals to, let's say maybe 3x, oh no, log 3x. How will you get your final answer here? Your dy dx, without minding what, without wasting your time, is equals to, differentiate this guy that you have here. If I differentiate 3x, what will I have? I'm going to have 3 divided by the original value, which is what? 3x. 3 can cancel 3. So dy dx is then equals to 1 over x in that point. So let's take one example according to what they said. They said if y is equals to log base exponential of, let's say, ax, let that h be, let's say a is 2, that's 2x plus, and let's say b is 3, 2x plus 3. So they say you should differentiate dy dx will be equals to, if you differentiate this guy, what I'm going to have is ordinary 2, because if I differentiate this one, I'm going to have 2. If I differentiate 3, I'm going to have 0. That's 2 divided by the original value, that's 2x plus 3. Final answer, which is very, very simple. Now let's now solve series of questions on this. Having this number 1 question, what we have in this number 1 is if y equals to ax to the power 3 plus 4x to the power 2 plus 5a. Now let's differentiate this. I said if y equals to a raised to power ax raised to power 3 plus 4x square plus 5a. Now that's for number 1. So how do I differentiate this? I can actually differentiate this one from first principle. I can make the work easy for myself. So I can say dy dx is then equals to 3 times a, that's 3ax, 3 minus 1, that's 2, plus 2 times 4, 8x, 2 minus 1, 1, plus 5a does not have x at all, hence it becomes 0, is a constant. Then my final answer is then 3ax square plus 8x. That's for number 1. Number 2. For number 2 question, the question is y equals to 3x plus 5 multiplied by 4x raised to power 8 minus 3. From here you can either use your product rule, or you should expand this bracket, open this bracket, then you use your first principle. So using my product rule, remember that product rule simply say that, I can even give you cheats in this product rule. This product rule, what product rule is saying is that differentiate 1, use it to multiply this, plus what it's actually saying is that keep this one as constant, don't differentiate it yet. Now differentiate the second one. Now once you differentiate the second one, use it to multiply this one, plus, remember I've not differentiated this one. Now the second part is now that differentiate this one and use this one to multiply it. That's dy dx is then equals to u dv dx. I will not differentiate this one, I will keep it, then I will differentiate this one, I will use it to multiply it, plus v du dx. I will not differentiate this one also, but I will not differentiate this one, then I will use it to multiply it. Very simple. Then I can say my u is equals to 3x plus 5, then du dx is equals to ordinary 3. Also my v is equals to 4x raised to power 8 minus 3. Then my dv dx is then equals to 8 times 4, that's 32x raised to power 8 minus 1, 7. This 3 is a constant, it will leave. So I think I'm done with this. I can say dy dx is then equals to u, look for your u, that's 3x plus 5 multiplied by dv dx. dv dx is 32x raised to power 7 plus our v is 4x raised to power 8 minus 3 multiplied by my du dx. My du dx is 3. So finishing this thing here, I can say 32 times 3 is 96. 96x. I have 1x here, I have 7 here. Take 1 with 7, that's 8. We've done that one in other indices. You can search the previous video and watch. The next one is 32 times 5. That will be 160 plus 160 s raised to power 7 plus 3 times 4, that's 12x raised to power 8. Yeah, the next thing just to do is just to simplify. So how do I simplify this? I can say 9 plus 12. 9 plus 12, 8 to 12 is 20. We remove that 1, that's 21. 21x raised to power 8. I actually add it up because they're having the same power, plus 160x raised to power 7. And for me, I can say, let me stop here. Final answer. That's for question 2. Now moving to question 3. Question 3, I have that this one is quotient rule. Y equals to 3x plus 5 divided by 4x raised to power 8 minus 3. So how do I solve this? I can say using quotient rule. What's that quotient rule itself? Quotient rule is just like that of product rule, but it is subtraction, then you are dividing with the square of your v. That means, remember, it is dy dx equals to v du dx minus u dv dx divided by v square. And then from here, what was my v? I remember I always tell you, take your numerator as your u and take your denominator as your v. So that means my u in this place is equals to 3x plus 5, then my du 3x plus 5, then v is 4x raised to power 8 minus 3. So that means from here my du dx is equals to 3, then my dv dx is equals to 32 s raised to power 7. So finishing this thing, I can say dy dx is then equals to my v, which is 4x raised to power 8 minus 3 multiplied by du dx, which is 3 minus u, which is 3x plus 5 multiplied by my dv dx, which is 32 s raised to power 7, everything divided by v square, which is 4x raised to power 8 minus 3 all raised to power 2. So right away from this place, let me create a space here. Right away from this place, from this down part, I've differentiated. Now the remaining thing is just to simplify. So I can say my dy dx is then equals, from here, that's 4 times 3, that's 12s raised to power 8 minus 3 times 3, that's 9. Then keep this minus into brackets. 32 times 3, that's 90, that's 6, that's 96 x. I'm dashing 1x to 7x, that's 8x, that's raised to power 8. Then the next one is 5 times 32, which is 160, that's plus 160 s raised to power 7. So finishing thing, I can say dy dx is then equals divided by this one. Just leave the square because if I say I should open, it's going to be very, very high. So that will be 4s raised to power 8 minus 3 all raised to power 2. So for this numerator part, 1, that's 12 minus 1 minus 96. 12 minus 96, I call that value minus 84. Minus 84 s raised to power 8. Also, I have 160x here. times minus, that's minus 160x minus 9 minus 9 raised to power 7. Okay, divided by this value, 4x raised to power 8 minus 3 all raised to power 2. I think I can stop here. Yes, although you can still simplify if you really want to simplify. To question 4 now. What's question 4? Now the reason why I change the ink in this place is that these parts, they look different from these parts. These parts are very, very simple. They are just O level side. Why this part is now coming to your A level. Now coming to this place, you can say y equals to log sine x base exponential. Y equals to log sine x base exponential. Now how do I log sine x base exponential? Now how do I differentiate this kind of thing? It's actually very, very simple. Remember, I've told you earlier that if you say y equals to log any value which is ax, your dy dx will be equals to a over ax. So finishing this work here, this can deal with this one. But coming back to this question here, what does it mean? Now let's say log sine x exponential base exponential. Now how do I differentiate this? It's very simple. Dy dx will be equals to differentiate sine x. If I differentiate sine x, what do I have? I'm going to have cos x. I've explained this earlier. Divided by the original value, which is what? Sine x. Divided by sine x. And then that's then equals to, normally sine x over cos x is equals to tan x. I've done that one in my previous video when I dropped my video on trigonometry function. Now we say normally sine x over cos x, that one will give us tan x. Now I'm not having the changeover, they have swapped it and they say cos x divided by tan x. That means I'm going to be having 1 over tan x, and 1 over tan x is the same thing as cos x. Final answer for this question here. So moving to question 5. Now this question 5, you will see that the function I want to differentiate is having a power. So how do I differentiate it? I said for number 5, y equals to 4 raised to power cos differentiate is in the power. The question is actually y equals to 4 raised to power cos 3x square. A power that is having another power. A servant that's having another servant. So what do we do here? Let's just differentiate it. Remember, whenever you want to bring this thing down, I want to show you a trick. When I say y equals to a raised to power x, and then I say differentiate this value, how can you differentiate it? The value you want to differentiate is in the power, hence you have to bring it down. The only method you can use to bring this thing down here is using logarithm, one rule of the logarithm laws. And I've dropped it in one of my videos in that logarithm part. That I say log a raised to power b is the same thing as b log a. So that means if I introduce log to both sides, I'm going to have log y equals to log a raised to power x. Now if I differentiate log y, I'm going to have, if I differentiate y, that's 1 divided by original value, which is y, then dy dx. Because here I'm differentiating with respect to y, not with respect to x again. Then equals to, bring this x to the back, x, differentiate a, that's, if I differentiate a, that will be ordinary 1. Then my final answer here will now be dy dx is then equals to, because I have to take this y away, so multiply both sides by y. That's x multiplied by y. What's the value of y? A raised to power x. And this is my final answer here. So coming using that same method, that same trick for this question 5. How do you think we can do it? Is by what? Introducing log ln y equals to ln 4 raised to power cos 3x square. Now from here, you might be wondering that what's ln? Ln is the same thing as log base of exponential, that's natural log. Okay, from here I can say ln y equals to this. So ln y is then equals to, now these guys which is here, they can come down. That's cos 3x square ln 4. Yes. Okay, from here I cannot finish this guy. Yes, I can finish it. Although you might be wondering that I should use product rule. I can't use product rule. Why can't I use product rule? Because in this place I don't have x there at all, so it is a constant. But here there is x here, so I'm only differentiating this one. So differentiating this guy here, I can say now let's differentiate. That's 1 over y dy dx is then equals to, now differentiate cos 3x square. Now differentiate this inside part, that will be 2 times 3, that's 6x. So 6x multiplied by, differentiate cos x, what do we have? That's minus sine 3x square ln 4, and that then equals to what? This y I have to take it away. That I can say y times 1 over y dy dx is then equals to 6x, that's minus 6x sine 3x square ln 4 multiplied by y. Y can deal with y, so dy dx is then equals to minus 6x sine 3x square ln 4 multiplied by y. What is y itself? Y itself is 4 raised to power cos 3x raised to power 2. So multiply by 4 raised to power cos 3x square. Can I stop here? Yeah, but let's finish it. 4 times 6, that's minus 24x. That's minus 24x raised to power cos. No, I can't do that, because the power here is 1, and the power here is, this one does not have x. I can't bring them. So this is the final answer for that question 5. Now moving to question 6. What's question 6 talking about? Question 6 is actually let's say y equals to, say question 6, y equals to exponential 3x plus 1 plus 2 raised to power cos 3x raised to power 4. So from here, how can I differentiate this straight away? It's very easy. Remember, I've told you earlier that if you differentiate exponential x, you're still going to have exponential x. This thing here is very, very stubborn. No matter how you differentiate it, you still keep having the same thing. So that means from here, if I want to solve this question 6, that means from here, if I want to solve this question 6, what do? I can say dy dx straight away is then equals to differentiate this upside. That's 3x, differentiate 3x, that's 3. That's 3 exponential 3x plus 1 plus differentiate this upside. This is 2 raised to power something. So let's take this one as another function on its own. This is our first answer. So let's dive to somewhere that, let's say, assuming that v equals to 2 raised to power cos 3x raised to power 4. So this one is just like, now this one question like this now is like the same question for question 5. So you can pause the video and solve it, then you get your answer. So let's move on. So we can say, if I want to solve this, I can say ln v equals to ln 2 raised to power cos 3x raised to power 4. So bring this upside, bring it down. That will be ln v equals to ln, that's cos 3x raised to power 4 ln 2. So finishing this thing, I can say 1 over v dy dx. Well, I don't even have dy dx, I have dv dx is then equals to let's differentiate this guy. Differentiate this place, that's 4 times 3, 12. That's 12x raised to power 3 into brackets minus sine 3x raised to power 4 ln 2. Now I have to take this v away. That I must multiply both sides by v. So v we cancel v, that's 1 over v times v dy dx equals to everything I have here times v. So v can cancel v, then my dy dx will then be equals to everything I have here, which is 12x raised to power 3. Okay, let me bring the minus out. That's minus 12x raised to power 3 sine 3x raised to power 4 ln 2 multiplied by v. What is v itself? What is v itself? What is v itself? V itself is 2 raised to power cos 3x raised to power 4. That's 2 raised to power cos 3x raised to power 4. Then from here, this for the second answer. So let's bring them together, the first answer and the second answer. That means dy dx is then equals to, the first answer here is 3 exponential 3x plus 1. So 3 exponential 3x plus 1 plus the second answer. Now what's the second answer? The second answer is the final answer I got here, when I say minus 12x raised to power 3 sine 3x raised to power 4 ln 2 multiplied by 2 raised to power cos 3x. This part can actually come to the back here. So that was, I'm going to be having plus into brackets minus 12 x raised to power 3 sine 3x raised to power 4 ln 2 multiplied by 2 raised to power cos 3x raised to power 4. If you like, you can stop here, and if you like to simplify, you can still simplify further. Now, and lastly, for question 7. For this question 7, what I actually have there is y equals to, into brackets, sec 3x minus exponential tan x, then everything plus 5 raised to power square root of x. This thing here is actually simple. So we can say dy dx is then equals to, straight away, if I differentiate this inside part, I'm going to have 3. That's 3. If I differentiate sec, I'm going to have sec 3x tan 3x minus, differentiate this exponential tan x, but before that, differentiate this upside. That's sec square x exponential tan x plus this one. You have to remember that it is having the, what I want to differentiate is having it as power. So how will it look like? You can actually pause the video and solve it. Let's say p equals to 5 raised to power square root of x. Now from here, I can say ln p equals to ln 5 raised to power square root of x. So ln p is then equals to square root of x ln 5. So from here, I can say, let's differentiate. But before differentiating, let's say ln p is then equals to x raised to power 1 over 2 ln 5. I've explained this guy when I was doing indices. So from here, let's differentiate. That's 1 over p. That's 1 over p dp dx. I'm differentiating p with respect to x equals to, differentiate this guy here, I'm going to have 1 over square root of x. Yes, because what I'm going to have actually, the exact number I'm going to have will be x, that's 1 over 2 multiplied by x raised to power 1 over 2 minus 1. So from here, I can say 1 over 2 multiplied by x raised to power half minus 1, that's minus half. And that's, whenever I have minus, I can bring it down. That will be 1 over, then that's 1 over 2 multiplied by 1 over x raised to power 1 over 2. And that's then equals to 1 over 2. Anything raised to power half. Anything raised to power half is square root of that number. That's square root of x. That means from here, what I'm going to have is 2 square root of x multiplied by ln 5, and finishing this thing, I can say multiply by p. What was my p itself? P itself is 5 raised to power 5 raised to power square root of x, then this p will cancel out. So getting our final answer for dy dx, this is just the p dx. So dy dx is then equals to call for this 3 sec 3x tan 3x minus sec square x exponential tan x plus, let's bring this 5x, let's bring it here, that will be plus 5 raised to power x, 5 raised to power square root of x divided by 2 root x multiplied by ln 5, and that's the end of this differential calculus. I'm supposed to give you cheats. No, I'll give you cheats in another video, then I'll post it to watch. So I think I've solved all the questions in this place. Please don't forget to like and share, subscribe, stay tuned so you can see for integral calculus also.